Okay, now let's look at another problem. A balloon is put in a bell jar, and the pressure, a bell jar, by the way, is a jar that has a attachment to a vacuum, so you can reduce its pressure. A balloon is put in a bell jar, and the pressure is reduced from 782 torr to 0.5 atmospheres. If the volume of the balloon is now 2,780 milliliters, what was it originally? And it gives us this conversion factor here, and you know that you can find these conversion factors in your text as well. Okay, so the first thing we want to do, always, is we want to write down what we're given. It gives us some visual clues as to what we're dealing with. So we have an initial pressure and an initial volume, and then a final pressure and a final volume. So this is a situation where we have an initial state and then a final state. Okay, so my initial pressure is 782 torr, and then my final pressure is 0.5 atm. And then we don't know what our original is. That's what we're trying to find. But our new volume is 2,780 milliliters. Now, one thing I did not point out in my previous lecture is that whenever we're using Boyles' law, and here it is right here, P1 V1 equals P2 V2, we want to make sure that our units are the same. So my initial pressure here is in units of torr, and my final pressure is in units of atmosphere. So I've got to convert either torr to atmosphere or atmosphere to torr. It doesn't matter which one we convert, as long as in the end both of our pressures have the same unit. Once they have the same unit, then we can plug them into this equation and just use our Matho 70 algebra to solve. Okay, now I'm going to write the conversion in red so it sticks out. I don't want to go to a new page yet. And I think I'm just going to convert my torr to atmosphere. It doesn't matter, as I said, but I'm going to take my 782 torr, and as it said on the previous slide, there are 760 torr in 1 atm. Our torr cancel out, and the units that we're left with are atm. And I'm going to let my calculator do the math here. And when I do, it tells me that I have 1.03 atmospheres in 782 torr. So my pressure 1 is 1.03 atm. Okay, so this is starting to get a little messy, so I think I am going to go to a new slide. So here's a summary of what we have so far. Our initial pressure, which is 780 torr, turns out to be 1.03 atmospheres. The pressure is reduced to 0.5 atmospheres. Our initial volume, or our original volume, we're not sure what it is, but our final volume is 2,780 milliliters. So now that my two pressures have the same units, I can go ahead and plug in. Alright, so pressure 1 is 1.03 atm. Volume 1 we don't know. I'm just going to label it volume 1. And that equals P2, which is 0.5 atm, times V2, which is 2,780 milliliter. Okay, so I'm going to do my math here. I'm going to multiply these two values together. And that's going to equal 1,390, and my units are atmosphere times milliliter. And then over on this side, I have 1.03 atmospheres times V1. Now I have an algebraic problem. I have something multiplied by an unknown value is equal to another value. So to solve for my unknown, since I'm multiplying it by 1.03 atm, I am going to divide both sides by 1.03 atm. Remember, anytime we do the same operation to both sides of the equation, it's completely legal. So my atmospheres cancel out on my right-hand side of the equation, and my number and my units cancel out on the left. So I have V1 is equal to 1,390 milliliters divided by 1.03. So I just do my math, and my calculator tells me 1,350 milliliters. Okay, does that make sense? Well, my pressure went down, so my volume should go up. And if my original volume was 1,350 milliliters, then yes, my volume did go up as my pressure went down. Always stop at the end of a problem to see if your answer makes sense. Not only will this help you in a test or quiz situation, but it also helps develop these concepts in your mind, because you have to replay the relationships. Don't just plug and chug and let your calculator do the work. Make sure that your answer makes sense at the end, which it does in this case.